Okay, we are live again. I got disconnected from the internet. I don't know why. I was explaining to you the comprehensions, syntactic sugar for the, in this case, for the math. Again, I'm getting interrupted again. I will take my time here. So one will take the place of n, two will take the place of n, three, and four. Then the expression will be applied. We will have one for 916. Right? Just in case you are here, like, and just you ended on this video and say, "Oh, I don't understand this." You see? But I'm going to write this. Let me explain it once more. For n that is being extracted from this list, one will become n, two n, three n. For n, this expression will be applied, and you will end with this n times n times n times n times n. Look at this beautiful result. It's time for us to write code for n in your list. Look at this. And yes, n times n. And you got your result. Now you're happy. Comprehensions are made of three parts: generators, filters, collectibles. Generators and filters. Now I'm going to be rather quick because I wanted to be only 20 minutes in here, but the internet. I don't know. Then I will play the guitar again. In the expression above, this is the generator, right? It is generator. You know how to read, but this is the generator, okay? And any variable can be passed on the right-hand side of the generator expression. That means you can experiment with a map, but we will not do that here. Look at this. We have some sort of range, and it goes until 4. It's inclusive for 2 points, inclusive for. Look at this. Even better, more beautiful. Generator expressions support pattern matching. Uh, all non-matching patterns are ignored. Okay, this sort it will behave as a filter. Good, good, bad, good, and then you apply this for values, which is this, and again you multiply m times n, but you are doing pattern matching, and you're saying only the goods, only the goods, this, this, and this. Since this does not pattern match, it is discarded. Discarded. Well, put, three values because we have one batch. So this is, remember, in your memory, write into your memory. Mm, pattern matching, and you can filter. It behaves like a filter. But I don't know. Look at this. These guys are ahead of the curve. I was thinking about now the classic example, even numbers uh, for n that is being extracted from here. Again, this is your generator. This. You can say n is being extracted from this. You have filters. This is your filter. Mhm. Again, the same. Only the multiples of 3. It discards uh, false and nil. All other values are selected. So I'm going to write this and we are just preparing ourselves for our Elixir Phoenix tutorial, which I I'm not sure. Need to I need to do some project. So I will read the Phoenix Web Framework tutorial as I do my project. I will try to plot the live programming. Mhm. Much more concise representation that using the equivalent functions from enum and stream. Remember, streams is lazy computing and enum is eager computing. So now you have the question, is this lazy or eager? It is more concise. It is syntactic sugar. That is a beautiful it is, Elixir. So now you are asking yourself, it's eager or lazy? Furthermore, comprehensions are also allow multiple generators. Okay, list of directories, and then you have this beautiful for uh, comprehension with several generators. Dir that is being extracted from dirs, file that is being extracted for file ls. This reminds me of Haskell, like my nightmares start. Oh my god, monads. But I am yet to deep inside that topic with one last lab that I have pending from another training. If I do that, uh, I don't know. But yeah, this is file that extracts from files. But this is easy. Dir comes from dir's. File is being extracted from this path, joining dir and file. Now you are using your values. And then you yield. Oh, you're asking a question here. So you are filtering in here, like in this rem. Now you're here, right? And you write your do, and you yield, if you come from Python, this result. Look at this. Multiple generators can also be used to calculate the Cartesian product of two lists. Okay, you have your atoms, remember, prefix column, atom, and then another generator, and then you do one tuple. So you are A with one, A with two, and now you are running out of J. So you came here and you grab B with one, B with two, and you now run out of elements for J. Come here, J, one, two, and you have your Cartesian product. Keep in mind, inside compressions, within generators, filters, or inside the block are not reflected outside the compressions. If you are doing some assignments in here, it will not be present. It will not affect or yeah, have an effect in the final result. Should we write this? Okay, let's write it. You can memorize this, but there is this guy, I don't know, saying that if I see, I forget. If I write, I remember. If I do, I master. How does the saying goes? If I see, I forget. If I write, I remember. Okay, so write, type, so you can remember, so you can't forget, right? I'm not sure what I'm doing here. Right? Okay. And you have your beautiful Cartesian product. 12 minutes plus the 5 minutes, 6 minutes, 18 minutes. So we have 2 minutes to finish this. Let's be very, very quick. Bit string generators are also supported. You have your pixels and you have your um, generator. In here, I'm wondering if they are doing some sort of pattern matching. Most likely, yes. Remember from our session in big strings, if this number is represented with this bit size, you get to retain it. But a little fade, and then it's making some triplets, 15, 60, 0, 0, 60, 60, there is 170. Oh, here's the other. 1, 2, okay. 1, 2. Let us count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we will have 4 triplets, which are here. Great. Again, I haven't seen too much of this in web applications. I haven't seen a lot of code anyway, so don't take my word. At least in Phoenix web framework. Now this looks a little bit cryptic, if that's a word. Okay, here's the into. Do you remember this? This is to extract the code point. Some people say that I have good memory, some other people say I have a brilliant memory. Uh, I'm saying that I remember little things that I don't practice, but I am not. Sorry, I am not. Memory is very volatile. Write things, practice things. I don't practice, but I want to do. I wanted to do this today. Yeah, you're extracting the code point, and you're saying that it's different from this thing. Probably this is on space and into, and you are putting the result in here. Look at this. Yes, and you retain the character, and you're removing the space. I think it's obvious, but it looks kind of. Someone will say, "Oh my God, I want to do that. I want to for the string to have point and replace point dot replace parenthesis comma."